Guten Tag. That ends my German. For the next 45 minutes, maybe a little less, I'm going to talk about what's going on in database management and what's going on in application development and how that might affect what database management technologies and practices get implemented in your data centers over the next few years, what technologies you may or may not be using to do that. So I'll talk a little bit about where we are today. Oh, sorry. Good? Thank you. I'll talk a little bit about kind of the database, state of database technology today, how we got here, how it's changing, and a few predictions, and really about the connection between what we call the operational brain and what's going on in data centers. How that's actually what you're doing and what you've pioneered is kind of moving out into the business and the world of things. So I'm from the Northeast United States, near Boston. I've been in the database management software business like forever. I love databases. I don't know why, especially new ones. And I think just being on the forefront of database management technology, you're usually in the forefront of software application development, and therefore on the front of how software is changing the way we live and do business and learn and connect with each other and stuff. So it's a lot of fun working with the customers I've met through each one of these databases I've worked with. I'm currently at Crate.io, developers of CrateDB. Anybody here hear of that, or a handful of you? It was founded actually in Western Austria. Also a big development office here in Berlin, and a bunch of us in New York City and San Francisco. So let's start with the NoSQL era, right? So kind of brief history of databases and kind of bring us up to where we are today. Prior to 2005, we were really in what Mike Stonebreaker, inventor of Ingress and subsequently Postgres and a bunch of other databases, called the one-size-fits-all era. That's where we had a handful of databases, most of which are still widely used today, most widely used today, that kind of did everything from data warehousing to transaction, processing to time series, geospatial, you name it. But really at the beginning of the 2000s, there were some companies, one of which was founded by Mike Stonebreaker, or a few of them actually, like Vertica, where I worked, that started to invent specialized databases for unique use cases like data warehousing and analytics, transaction processing, text search and things like that. And that really led to this explosion of specialized databases, and we went from 5 to 10 databases to 10 to 20 to now probably easily over 100, right? Many of the NoSQL databases, especially the popular ones, really were born out of necessity. Giant internet companies like Amazon, Facebook, Google, LinkedIn, had to invent databases that were economical to run at the scale at which they did business, right? Using Oracle to power Amazon's e-commerce would have cost $1 bajillion. So they spent less than $1 bajillion inventing DynamoDB, for example, and some other databases. And then, they gave back to the technical community by publishing, white papers or open sourcing their code. Facebook with Presto, Google with, Spanner, and so on. And from there, it really kind of set a bunch of development communities off building derivative works and forks that have become really the NoSQL ecosystem that we know today. So let's start with kind of the good, bad, and ugly of NoSQL. Okay, the good is that it really allowed us to more easily process data that didn't fit in rows and columns very nicely. JSON, of course, key value stores, allowed us to do, process richer information and in new ways, text search being an obvious one. But by and large, they're known for the ease with which they can scale out to handle more users, more data, the ease with which they can handle new development requirements. Okay, just throw a bunch of new data structures in the in your data store and write MapReduce or whatever access sort of language they support to to get data in and out. So very easy to use from a developer standpoint. Also open sourced. So unlike the era before it, it was really inexpensive to create and deploy very powerful data management database applications. Okay, and of course all the communities that arose from these that connect us today. It also helped a lot of us learn what the CAP theorem is and what ACID are. I'm not going to go into detail on this, but what it also helped us learn was what the world would tolerate. If you went back to 1999 and said, I'm going to create a database that may or may not be sure if your transaction was committed, right? Or you may or may not be reading the latest version of a record, it would be sacrilegious, right? Today, of course, eventual consistency. We've learned to live with it. We've learned that that's kind of been the business model of things like banking and airline seat reservations. When we show up to take a flight and we find out the plane's been oversold, right? So we kind of learned what we were able to tolerate and what kind of myths existed around the way a database had to work. So on to the bad. Okay, so these would be things like really no standards arose around, still really have not arisen around NoSQL. It was really just a, kind of a venture capital and startup race to gather market adoption, and MongoDB kind of won that. But it really made this lack of SQL, literally, meant that any developer moving on to a NoSQL database project had to learn a new way to access the database. So there was a learning curve. Database administrators had to learn new ways to tune and implement, deploy, secure these databases to help them grow. A lot of these databases, while they promised, simple scalability, Crate DB being one of those, they're not always that simple. You really had to, in some cases, master nuances, in the databases or slight differences, and also a lot of the technology that was used to scale those load balancers, today the container environments and so on. And I think what really limited the growth and adoption of NoSQL databases most was the fact that there were so many of them, and it was really hard to tell the difference between them, right? They were all very specialized, and to somebody kind of stepping out of SQL Server world and into NoSQL, it's like, I'm going to use MongoDB because I've heard, it's what everybody uses. But that may not be a great choice, okay? So, people were hard-pressed to tell the difference between a Rethink and a MongoDB, or a Couch and a Couchbase, CouchDB and a Couchbase, or even Couchbase and MongoDB. So, it was a lot of learning just to figure out which those databases was going to fit your need. Okay, in some cases, people would deploy multiple types of databases. A lot of you have seen applications that use MySQL or Postgres to manage tabular data, relational data. But also that same application will use something like Elasticsearch to store unstructured or full text data. That's actually how CrateDB was born. A CTO of StudiVZ, right? The kind of biggest social network before Facebook came to Germany or Europe. Just got kind of tired of having to support both of those and said, why don't I invent a database that's kind of the offspring or the child of those two things. So that's what Crate is. And then the ugly, and this is where we use the word consolidation. It's an industry term for when companies go out of business and you go from having lots of competitors in a business to fewer, or they get acquired. But we lost a couple of good friends, Rethink DB. By lost, I mean the companies, the commercial companies behind them went out of business. Rethink DB, React, both kind of last year. Foundation DB, I put the little Dracula Lego there because they went away when Apple acquired them, but they were relaunched this year as an open source project by Apple, so they've come back to life. But you know, one of the predictions I'll have, no surprise, is that this list is going to keep growing. Okay, so one other kind of observation or remembrance I have, I'm kind of like a historian, right? A database anthropologist. I'm so old, I've seen all these databases come and go. Kind of have a good feeling for what's going to stick around, what isn't. But about 10 years ago, Mike Stonebreaker and some of his colleagues published this article, and suggesting that at the time, right, where really Hadoop was kind of what they were talking about, that MapReduce and NoSQL databases were going to be a big step backwards for database technology, right? They made a lot of good arguments. They caught a lot of flack, right? A lot of heat from people who disagreed with this. Certainly the history of success people have had with these databases, the amount of venture capital investment and kind of end user investment has proven them wrong in ways. But I look back on it and I think that it was actually quite a big step forward. And while they were right and that a lot of us went through lessons and learned lessons again that the SQL pioneers, Postgres and MySQL and Oracle had learned, MySQL Server had learned over decades. We learned those over again over the last 10 years. But it did help us learn that things like ACID, wasn't an absolute necessity. We could live with eventual consistency. We learned that we could live without SQL access, right? Even though it made integration and staffing projects a little bit harder. Okay, and so I think those learnings, plus the source code, all the open source code that got created over the last 10 years, is really helping to create a new generation of databases. Yet again, okay. So if we look at, we kind of went from monolithic SQL to distributed SQL to distributed NoSQL, and now we're coming back to distributed SQL. Okay, and what's going on now are companies like, or open source projects like CockroachDB and CrateDB are born out of kind of SQL and NoSQL. Okay, both of these companies and more to come, or more that are coming, are written, distributed SQL layers, but instead of using kind of traditional relational storage and indexing beneath that, the query planners and execution layer, they've taken code from NoSQL databases. In CockroachDB's case, they took from RocksDB, and they really specialize in cross-center transactional processing. CrateDB took Lucene, right? So every shard in CrateDB is a Lucene engine. So for those of you in the data center, it's kind of like got a database that can do time series analog analytics all in one now. So I think the next, one of the predictions and one of the things that I think you'll see increasingly over the next few years is sort of NoSQL and SQL technologies coming together in a much tighter way than just a SQL interface to a NoSQL database or translation layer. Let's talk a little bit what's changing in the business and what's changing in application development. And whether you know it or not, everybody here who works in a data center who's built or runs systems monitoring and alerting has actually inspired a lot of what's going on in the business. But when we talk about the operational brain, we're really talking about the development of applications that are becoming more predictive, right? They're using machine learning, artificial intelligence, algorithms, data science, to go from applications that are simply a user interface into a database, but now actually will predict, right, or even control things in the business or things in the factory, things, products. And so this is going to have a profound impact on the kinds of databases and what's going on with data in the data centers. One example, the company Alpla, which makes all the bottles, plastic ones, 180 factories around the world, and they had a problem with turnover or workforce, hiring people in the factories, training them on how to use this, kind of very specialized and technical equipment, bottle making equipment, and then they would go find other jobs. So it was very expensive to train people and then having to rehire them. And the head of operations for Alpla in the US had this idea. He's like, these machines generate so much data. Every factory's got 900 different types of sensors running, and those data from those are mostly used by the machines themselves to, kick defects out of the process. But he's like, what if we could take that data and, put it in a room full of monitors for this guy, right? And he could, instead of walking around the factory looking at machines by eye, listening to them, watching them, checking dials and stuff, he's provided with information from all those sensors, okay? Kind of like some of you are watching or at least waiting for PagerDuty to inform you that there's something going not quite right, okay? So they started to feed all this data into operations, and they tried using SQL Server. They felt like that was the right thing to do since they're a big Microsoft shop, and that's what their developers knew. So some poor person had to create 900 different tables, one for each type of sensor reading, and it didn't work so well. They ended up switching to another database to get the real-time visibility they needed, so that these dashboards would refresh in just about a third of a second instead of an hour, which is about the same time it took the guy to do a lap around the factory. But what's really cool here is that this using data this way, when he sees a problem, and it can just be it doesn't have to be severe, like a machine has stopped running. It can just be a machine that's using more plastic than normal, right? If it uses too much plastic, the bottles are defective. It doesn't use enough, they're also defective. But they want to be using just enough line, otherwise they're wasting raw materials. But when he sees those, he's like a human PagerDuty. So he'll get in touch with a person on the factory floor who now does not need to be as trained and as expert as this guy. And they connect through augmented reality, the Microsoft HoloLens. So he can see what the person on the factory floor is seeing and annotate their field of vision and bring up videos and manuals and step them through the repair of the machine, replacing parts, machine adjustments and stuff like that. So it's very cool, and it's had a huge impact on the way on Alpla's profitability and the way they manage their workforce and kind of retain knowledge through data. So, but that should sound a little bit familiar from anybody who's in a systems monitoring standpoint. It's just like systems monitoring for bottles. Okay, so this is really going to change the kind of way data's, what and how much data comes into a data center, right? So unlike logs from a server and systems monitoring, or even the IoT or industrial IoT, Industry 4.0 data, from machines is very complex. It could be tens or hundreds of data points per JSON object, and like I said, 900 different messages. So, the ability to process that kind of information, many data points per bottle, right, or per machine per day, to combine that with information like who was operating, HR data, like who was operating the machine at the time, natural language processing, right? What can we learn from notes that the operators have entered in different languages? Same machines around the world, but different languages that they're typing in sometimes. About problems and fixes to those problems, right? Material suppliers, a lot of returns on a bottle. That could have been something about the manufacturing process, but more likely the quality of the ingredients or materials they used. Okay, so a lot more data coming in. Data integration is going to become a bigger challenge for the business and the data center as well. Okay, so simply put, just get ready for what we call just a fire hose of weird data that needs to be analyzed in real time. Okay, almost always in the cloud, but sometimes out at the edge. Like at Alpla, they have central database with all this stuff they analyze, but they also have this stack at each of their 180 factories for local analytics. Okay. I have 3 more predictions. This is probably going to go a little quick today, so you can get out early. Okay. So I think just some of the other things I think are going to change in database technology. I think that middleware and database servers are going to start to blend. Okay. If you think about some things like message queuing, okay, which was invented, 10, 15 years ago, maybe more. Those were invented because databases you couldn't depend on a database to run all day. You certainly couldn't depend on the database to process tens of thousands of messages per second. So you had the message queuing, which kept stuff safe, even if the database wasn't. Okay, but databases today, the scale out, it's easy to build replication, kind of very high uptime, very high ingestion rates with eventual consistency and things like that. So databases like CrateDB will embed MQTT. We've embedded an MQTT listener into Crate, so this really kind of eliminates the need for a separate MQTT broker in between Crate and the data sources. Prediction 2, time series databases. This is kind of funny. I mean, they're useful, they're interesting. There's a definite need for time series data management. I've seen these come and go over the years. There's always a new need for time series, but none of these ever really gain commercial traction. I think in the data center, use what you will. This is more kind of for investors. Like, why are you putting $20 million into these? There's very little. It's kind of a small data problem, and really a small market for these. And I think the one exception is Prometheus, which has such a great foothold in systems monitoring, right? Kind of event and metric management, and it's such a great fit for the use that I think that's just going to end up being the de facto standard, and really is in terms of all the different system software that already supports Prometheus as an endpoint. Okay, and the last thing, I just think SQL is going to continue to dominate, right? I think it wavered a little bit with the NoSQL era, but by my last count, the number of NoSQL or SQL developers just on LinkedIn, people who had the skill, SQL Server to MongoDB specifically, was around 45 to 1, right? So throw a rock in here for how many people know SQL or have used it? Show of hands. Okay, how many people have used SQL? C, right? Cassandra's, right? Not as many. So it's easy to staff SQL projects, and I think with the exception of MongoDB, which has really reached what I'll call escape velocity and has a really critical mass of users behind it, and will probably be like the Mark Logic, which started as an XML database of like 2025. But there's really, as the SQL databases, not just new ones like Cockroach and CrateDB, but even the advances that continue to happen in MySQL and work that Percona and others do, Postgres, that the capabilities you get in NoSQL are just going to kind of become less and less valuable to people. So, I think that So I don't think you need to be in as big a rush to brush up on NoSQL databases so much. I think just final thoughts, really, kind of for people in the data center is, it may not be obvious, but from somebody who's kind of up to his eyes in this machine data management and AI and IoT application development, a lot of what companies like Alpla are doing to monitor and manage and predict and control and automate the way they make bottles, right? Or energy drinks, or what have you. There are really strong parallels to what's going on in the data center, right? So I think a lot of what The technologies and practices, especially the open source ones that have been applied in the data center to keep IT infrastructure up and running are really starting to be applied towards physical things and other parts of the business. So whenever you hear something that doesn't feel like it's working optimally for the business outside of IT, start to think about, kind of apply your systems monitoring and, availability, security, brains towards those problems, and I'll bet you'll find some analogs and some solutions you can apply. Any questions? Crickets.
Are there any questions left?
Okay.
Okay.
You get out early.
Yeah, I think so.
Thanks.
Thank you, Andy.
Pleasure. Thanks, everybody.